Property of triangles in general is the angle-side relationship. This one is really straightforward. In a triangle, the side opposite the largest angle is the longest. So, in this triangle, 97 degrees is the largest angle. Across from that, the side opposite that angle, that has to be the biggest. If this is the biggest angle, across from that, that has to be the longest side. Same works with the smallest one. That's our smallest angle, 24 degrees. Across from that, that has to be the smallest side. All right, so we're going to write the sides in order from shortest to biggest. So first off, we need to figure out that third angle. If that's 55, that's 62. We subtract both of those from 180. We see that that is 63 degrees. So that is our biggest angle. That means across from that is going to be our biggest side. So AC has to be the longest. Across from the 55 degree angle, AB, that has to be the shortest. And across from the middlemost angle, that is our middlemost side, that is BC. So that's the order from shortest to longest. Second one, in triangle ABC, we have these three sides. AB is 3 inches, CA is 4, CB is 5. Write the angles in order from smallest to biggest. I'm going to draw this picture. I just happen to know that that's a right triangle. It doesn't have to be perfect when you draw this. A to B to C. A to B is 3. C to A is 4. C to B is 5. So we're trying to write these angles in order from smallest to biggest. Well, the one that's across from the biggest is going to be the biggest angle. So let's say that's angle CAB. That's the right angle. It's got to be the biggest in a triangle. This is our shortest side, so across from that is going to be our smallest angle, really. That's angle ACB. And then this angle has to be our middle one, angle ABC. All right, on the third one, we're writing these side lines in order from shortest to longest. We're going to write all 5 of these side lines, A, B, C, D, and E, in order from smallest to biggest. All right, so let's just look at this small triangle, or this triangle on the left side first. 133 degrees is measuring that angle. That means across from that, that has to be the biggest side in this triangle. So out of A, D, and E, side E has to be the longest. That's just dealing with that triangle. If I look at the second triangle, if this is 49, this is 85, this has to be 46 degrees. So if I look across from that, now side E has to be the shortest side. So this is a little bit confusing. It's the biggest side in this triangle, but it's the shortest side in this triangle. It really just means that all 3 of these sides are bigger than these 2 sides. This is just a bigger triangle. This is the shortest side. Side E is the shortest out of any one of these 3. But I know that this is a bigger triangle because it's the longest. This side E is the longest side in that triangle. So I know that A or D have to go in these 2 spots. I know that B or C have to go in these 2 spots. And I know that E has to go in the middle. It's the shortest out of these 3, but the longest out of these 3. So now I can really just deal with it one triangle at a time. I know that that's the shortest. I'm dealing with this red triangle first, big triangle first. It's the shortest side in that triangle. This is 49 degrees. That means across from that, that has to be the second longest or second shortest. So angle 49 is opposite side C. That has to be our next biggest. And then side B is across from this 85 degree angle. That's the longest side out of any of these 3, and it's the longest side out of any of them because we know that these 3 sides are bigger than these 2. So B is our longest side. Using that same logic, if this is 32 degrees, that has to be 15. So across from that 15 degree angle, that has to be our shortest side. That has to be D as our first one, and A as our second one. All right, that is the angle-side relationship in triangles.